Well, sometimes I admit I'm a little too cautious, but a paper that has just been published by the World Health Organization suggests to me that maybe I'm right to be cautious. Well, hello and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam, and I've been living with multiple sclerosis for 38 and a half years almost. And one of the things I enjoy the most is looking at the research and information that's being put out in the scientific literature and making sure that you're aware of it. And the paper that just recently came out needs to be shared and talked about. So I went ahead and linked to a video by a man named Dr. Campbell. And I don't know if you're familiar with him. He's become quite famous on the internet in the last few years. He is a doctor, a real doctor, but his training or his focus has been on training nurses. At the same time, he's very scientifically literate, so he's kept us up to date on lots of interesting topics. And the one that he's going to talk about today, I know you're going to find very interesting. I've only extracted parts of his video, but I will link to the whole thing below, also to the papers that he cites, so that you can take a look at these for yourselves.
Well, a warm welcome to today's talk, Monday the 29th of May. Now, last week the World Health Organization put out a release showing that there was a possible causal relationship between COVID-19 vaccine and multiple sclerosis. Now, this is the paper here. Now, it says COVID-19 vaccination can induce multiple sclerosis via cross-reactivity with T helper cells. Now, what is this actually showing? What is going on here? So what we have here, imagine this is a nerve fiber here. So the nerve impulses will travel down here, and this will be in the brain or the spinal cord. And these nerve fibers are surrounded by this protective myelin sheath. And in the central nervous system, they're made by cells called oligodendrocytes. Here we have the spike protein from a natural SARS coronavirus 2 infection. And here we have the spike protein produced by the vaccine on its own. Now, in learning to recognize, this is the CD4 lymphocyte here, the T helper cell. This is the famous T helper cell that's disordered in HIV. So when people become immunocompromised in AIDS, acquired immunodeficiency syndrome, what actually happens is the virus destroys a lot of these CD4 helper cells until they can't produce any immune response. But here it's not lack of immune response, it's too much immune response. That is the problem. So the CD4 is learning to recognize, rightly as in the principles of vaccination, these spike proteins, and it can beat up these spike proteins, which of course is good. These are the spike proteins produced by the vaccine. And the idea is that will help the CD helper cells to get rid of the spike protein should there be a natural infection. The point is the same sort of chemical profile that we're finding on the surface of the spike protein molecules there. We're finding very similar proteins on the surface of there are very similar proteins on the surface of the myelin sheath. So the T helper cells are also orchestrating a response which beats up on these myelin sheaths. And when the myelin sheaths go in the central nervous system, that is multiple sclerosis. The myelin sheaths, of course, are essential. They facilitate what we call bouncing transmission, much faster, so-called saltatory transmission of nerve fibers. They nourish, protect the nerve fibers. So that's what seems to be happening, and that's reporting on this paper. Anyway, let's look at it in a little more detail now, because it's a pretty significant paper. And it's not only showing what this particular autoimmune reaction is to multiple sclerosis, but is there other autoimmune reactions? Now, this is the paper here. COVID-19 vaccination can induce, now this is the WHO, so can induce multiple sclerosis via cross-reactive T helper cell, CD4 cells, recognizing SARS coronavirus 2 spike protein and, as we've said, myelin, this essential myelin that protects the cells in the central nervous system. Now, the article goes on. Both natural infection and mRNA-based vaccinations can be accompanied by transient autoimmune phenomena. This is actually a pretty big breakthrough. Let's hope this paper stays up, because it really is quite a groundbreaking piece. Now, they're saying it's a temporal relationship to the spike protein vaccine. In other words, the vaccine came first and the multiple sclerosis came second. Does this mean there's an automatic causal correlation? No, it doesn't. But we go back to the title of the paper. COVID-19 vaccination can induce multiple sclerosis. So the very title of the paper is indicating that there is a causal relationship. At least that's the way I read the title of that paper. The aim of the study, the onset of multiple sclerosis in 2 cases, very likely, so they're saying very likely caused by the CD helper cells that cross-recognize SARS-CoV-2 spike protein from myelin proteins. The results: self-reactive T cells were detected from spike-specific T cell populations. So the vaccine in that sense worked. It stimulated the T helper cells, but also showed reactivity against various proteins. Now, this MBP we'll look at in a minute. The MOG is the myelin oligodendrocyte protein. Now, what that means is this is the central nervous system. Here's the myelin sheath, and in the central nervous system, this myelin sheath is produced by the oligodendrocytes, or the oligodendroglial cells. So it's a protein that's specific to these cells that are producing this myelin sheath, the oligodendrocytes. So these are specific myelin-related proteins. Now, I'm just going to give a quick, this is papers in parentheses here, but this is just to give some insight. This is about multiple sclerosis and myelin-based proteins. Myelin-based protein, so this MBP that they found the cross-reactivity to, one of the ones. So there's cross-reactivity between the myelin oligodendrocyte glycoprotein and the spike protein. And there's also cross-reactivity between this myelin-based protein here. It's a central nervous system protein in the myelin, as MBP has long been studied as a factor in the pathogenesis and the beginning of the autoimmune neurodegenerative disease, multiple sclerosis. So this is not new science. This is well established. It is the cross-reactivity with the antibodies produced from the vaccine that is new. So getting back to the paper, finally we found pro-inflammatory T cell clones. So in other words, the T cells were involved as well. Now, the T cell involved here just seems to be the T helper cells. Whether other ones were involved, we're not told. But anyway, these pro-inflammatory T cell clones, like the CD helper cell, the CD4 cell, they recognize spike protein and immunodominant myelin-based proteins. In other words, they're beating up on the myelin sheath as well as the spike protein. And as we said, myelin oligodendrocyte glycoprotein peptides, which have previously been implicated in multiple sclerosis. Their conclusion: detailed studies of both peripheral blood and cerebrospinal fluid derived CD4 plus T cells, that's the CD4 helper cells, the T helper lymphocytes, shows that the onset of multiple sclerosis in these two very likely caused by the T helper cells, the clones, the population of these cells that are developed, that cross-recognize SARS-CoV-2 spike protein, derived peptides, and peptides derived from myelin proteins. In other words, it's beating up on the same. Similar structures, similar molecular structures in both of these areas. Beating up on the spike protein is good. Beating up on your own myelin in the central nervous system is potentially disastrous. Now, this is a bit alarming because this is not new. Now, this is a paper here. This is another paper. New diagnosis of multiple sclerosis in settings of mRNA COVID vaccine exposure. This is published in January 2022. So this is based on data collected in 2021. Multiple sclerosis with onset in the settings of acute SARS-CoV-2 virus infected people has been reported. So yes, it's possible after natural infection, and reactivity of multiple sclerosis following mRNA COVID vaccines. There have been 3 reports of newly diagnosed multiple sclerosis following exposure to mRNA COVID vaccines. So yes, that is occurring in 2021. The association cannot be determined to be causal, of course, because it could be caused by other factors. But it's temporal correlation, whereas the new WHO paper goes further and says it's now likely. We report a series of 5 cases of newly diagnosed multiple sclerosis following recent exposure of mRNA COVID vaccines. Now, latency from vaccination to initial presentation varied. Neurological manifestation in the clinical course appear to be typical for MS. So the time between people getting vaccinated and developing the features of multiple sclerosis varied. There was latency. How long could this latency be? We don't know. In these cases, it was fairly short because, of course, the vaccines only started in 2021. So these must have been within the course of a year. Are there more to come? We don't know that. So their conclusion was acute neurological deficits in the settings of recent mRNA COVID vaccination and administration may represent new onset multiple sclerosis. So we knew that in 2022.
Well, you know, I remember back in the way early times when I was diagnosed with MS, I was cautioned against doing anything that would stimulate my immune system. I wasn't supposed to take echinacea. I wasn't supposed to take live vaccines. There were many things that were kind of off the table for me because the concern was my immune system, because of my MS, was going to be hyperactive, not underactive, hyperactive. And that would be true for anyone with MS. So I got used to the idea that I should not do anything to stimulate my immune system. Along comes this and makes me think, yeah, I guess maybe I was right to be a little bit cautious. But what do you think? I'd be really interested in your reactions to this. I have not seen this talked about anywhere else. But the papers are out there. You can certainly read them. I would be interested to know what you think. Well, that's all I had for you today. I just wanted to get this out because it is pretty timely. So until my next video, please take really good care of yourself. I'll see you again soon.